Hey there, geometry. We are on page 32. This is section 3-3. We are going to continue learning more about the language of geometric proofs. And this one at times feels a little bit like a tongue twister, so hang in there. We're going to talk about the language of converse, inverse, and contrapositive. And I'm going to try to fit this on this page, but I really don't know if that's going to work, and it might be better at some point, I'm getting ready, that we just have lined notebook paper because I can't write as small as the printing company can print on a page. So here we go. We're going to take a look at this concept of a conditional statement again. So the example they gave us, if a figure is a triangle, then it is a polygon. So we know what a triangle means, like that's a triangle, but do you guys know what a polygon means? So a polygon is a shape in particular that does not have curves. It has sharp sides that come together at a vertex or a point, and they don't like cave in on each other. So we're going to talk about convex polygons, and I'm going to give you just some examples. I know that wasn't the best of definitions, but the book assumes you know what a polygon is, but it doesn't define it again until like chapter 33. Welcome to our world. So here's some examples of a polygon. Let's see if you get the pattern. Triangle, quadrilateral, but a quadrilateral could be a rectangle, a square, a rhombus, a kite, a parallelogram, a trapezoid, and I've probably forgot some along the way. Or a pentagon or a hexagon. I'm hoping you kind of have the idea. So, a triangle is a special type of polygon. If it's a triangle, then yes, it is a polygon by definition. Well, now our task is to learn how to write the converse. So if you guys look up here, remember how we had our hypothesis and our conclusion, and I did them in yellow and then purple. And I'm hoping that this clears up and refocuses. Okay. If you guys look at the converse, see what happens to the P and the Q? They flip. So what the converse does is it flips your conditional statement. And I know you can't see that because that's what my equipment does all of the time. Will I ever get new equipment? No, I won't. Clear up. Come on. Maybe if I zoom in, that's not better. Clear up. There we go. So we can see that the converse is going to flip the conditional statement, and I'm trying really hard not to move because you won't be able to see it if I do, because my equipment is being very particular today. It knows when I don't like it, and it knows right now I don't like it. So see how they flipped? Yep, see it's focusing in and out. It knows I'm not happy. So hopefully that makes some sense. So when we come down here to this statement, what we're going to do is we're totally going to flip it. And I know it's probably going to zoom in and out and be really frustrating. If a figure is a polygon, then it is a triangle. I don't even know if you can read that. So we're going to just do 2 pages right next to each other. This is kind of a tough lesson to teach remotely, but we're going to get through it because we don't have a choice. So the converse, remember I'm going to flip it. So I'm going to say if a figure is a polygon. See how that conclusion suddenly comes up to the front? Then it's a triangle, and that hypothesis moves to the back. Okay, is that true? If I have a polygon, is it automatically a triangle? No. A square, a rectangle, a rhombus, a polygon, holy cow, there's a ton. They're polygons, but that is not a triangle because it doesn't have 3 sides. Okay, so let's take a look at the inverse. Notice the inverse up here. P and Q still come first. Or P comes first, then Q happens. But notice what happens in front of them. We say not. It's called negating something. I'm not going to attempt to write in that teeny tiny spot. I'm going to put the inverse over here. So the inverse, leave everything in the same order. If, forgot the if, a figure is, and then we're going to put the word not. That's what's special here. If a figure is not a triangle, then it's not a polygon. Okay. So it keeps the original statement in the original order, but it puts not in front of those. Okay, so if a figure is not a triangle, then it can't be a polygon. I'm going to put an F for false and a T for true. That's false. So give me a figure that's not a triangle, that is a polygon. Like, does that make sense? So if a figure is not a triangle, a square, so I'm going to use a square, then I'm trying to tell you it's not a polygon. That's not true. So I'm going to use my crappy little picture of a square again. Okay. So let's try the third piece, the contrapositive. So let's look at what the contrapositive says. The contrapositive, notice how it has the nots. But then notice what happens with our letters. Q is all of a sudden first, and P is all of a sudden last. So the contrapositive is where we take the converse. We switch the order of P and Q, and then we add in the inverse and we do double knots. Oh boy. So the contrapositive. So I have to look at my pattern. I have to say, if a figure is not, the contrapositive uses not. And then I have to go to the end, the conclusion of the original statement. If a figure is not a polygon, then it's not, and I go to the front, the hypothesis of the original statement, a triangle. Okay, so if something's not a polygon, can it be a triangle? Well, no, because every polygon is a triangle. So that's a true statement. Now you might be like, well, what about a circle? A circle is not a polygon. No, it's not, and it's not a triangle. Huh. Okay. These are weird. I totally get that they are weird. So, we are going to do some more practice, because that truly, truly is the only way that we can get through this this assignment, this task, this section. And I'm looking ahead and just deciding. I think I want to do number 5. I think I'm going to skip through the top stuff for just a little bit. Let's just practice this. So number 5, and I'm on page 33, says, consider the statement. Numbers that do not end in 2 are not even. We need to rewrite this in an if-then form, and we'll decide if it's true or false afterwards. So let's do this. If a number does not end in 2, then it's not even. So does not end in 2 is our hypothesis. Our conclusion is not even. I'm not going to talk if it's true or not. We're just going to get the statement. So now our job is to write the converse. Okay, the converse says flip it. So if a number is not even, so notice how the conclusion came to the front, then it does not end in 2. Notice how that hypothesis comes to the end. So that's a converse. Okay, let's address the inverse. So the inverse takes the original statement, but it says the opposite. Okay, let's figure that out. If a number, now it already has the word not, but if we look at the concept of an inverse, it says not. So do I do not? So if a number does not end in 2, well, doesn't not mean yes? I'm going to get rid of the not. I'm hoping you guys can see that the not, in or out, deals with the converse. So if a number does end in 2, then I'm going to get rid of the next not. It's even. We'll deal with true and false later. Let's do the contrapositive. Okay, contrapositive, if we look at the colors, it switches the original statement and then negates them. It does the opposite of them. So I'm going to switch the original statement. If a number, then I'm going to come down here to not even, but I have to negate it. So if a number is even, I have to state the opposite of not even, which is even. Then it, I'm going to come up here, does end in 2. I have to negate or state the opposite of not ending in 2. The opposite of not ending in 2 means it does end in 2. Boy, this is very different. I wish we were on the whiteboard and everything was color-coded and life would be better, but it's not. So this is what we have. So let's talk about the truth statements. So on part A, if a number does not end in 2. So think of a number that doesn't end in 2. 17. Okay, then it's not even. Well, that worked. But do all even numbers have to end with a 2? Can you guys think of an even number that doesn't end in 2? Yeah, guys, this is false, because if we think of the number 44, that's even, but it doesn't end in 2. So it does not end in 2. Not even. That doesn't work. Okay, part B. If a number is not even, then it does not end in 2. Give me numbers that are not even. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. If it doesn't end in 2, aren't they all odd? So if a number is not even, then it's odd, right? It does not end in 2. That's a true statement. Okay, part C. Write the inverse and state whether it is true or false. Okay, if a number does end in 2, like 2, 12, 22, 32, 42, then it's even. That's true. Okay, part D. If a number is even, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, etc., etc., then it does end in a 2. Is that always true? Nope. The number 14, it is even. It does not end in a 2. Okay, there's a pattern here. Okay, this pattern, the truth statement of the original matches the truth statement of the contrapositive. The truth statement of the converse matches the truth statement of the inverse. And it works over here too. But I can't tell if my computer is still recording because my computer just shut down. But I think it's still recording because my ticker tape says that it is. So that means I have to stop, even though we're not done with the video, because I can't see what you can see, and my equipment does not allow me to pause. So we're going to unfortunately have the unpleasant experience of another video to go with this section. I apologize. All right, I'll catch you soon.